Okay, here's another example. Now, if I just try to, substitute large values of x that are negative, it seems like I get this, it seems like this is approaching infinity. So the square root is still approaching infinity. And then here I'm going to have negative infinity. So I get something indeterminate like this. So that doesn't really get me anywhere. I need to do some algebra. What I'm going to do is I'm going to multiply this by the conjugate, root x squared minus 9x minus x over the same. So I'm really just multiplying by 1. If I do that, I end up with x squared minus 9x minus x squared over this denominator. And here I have the limit as x approaches negative infinity of 9x over this expression, minus x over here. Okay, so in this case, now I end up, if I try to plug this in, or very large values, I end up with what looks like infinity over infinity plus infinity. So that's not really getting me anywhere. And I'm going to divide the numerator and denominator by the largest power of x. So I get negative 9x divided by x over so in the numerator I am going to get negative 9. In the denominator I'm going to want to pull this into the root. So I'm going to rewrite my negative x. So my x is a negative number, which implies that x is equal to the negative square root of x squared. And I can rewrite the denominator as this expression. Now simplifying a little bit gives me negative 9 over this expression. I'm going to perform the division in here. This leaves me with this expression. And now taking the limit as x goes to a negative infinity, my numerator stays the same. In the denominator, I see that this is going to 0, so I have negative 1 minus 0 minus 1, and this gives me negative 9 over negative 1 minus 1, which is negative 9 over negative 2, and my limit is 9/2. And you can see that right down here. I've just plugged everything in. So you can graph this function to convince yourself that this is the limit as x approaches negative infinity. I'm just going to do a couple more examples of things that can happen. So here I have a polynomial, and as x approaches infinity, it seems this term is going to infinity, and then this term is going to infinity. So this is indeterminate. It doesn't give me any information. Infinity minus infinity is not 0, because these are not real numbers, so we can't perform arithmetic. However, what I can do is I can factor and when I factor, I can see that this is approaching infinity. X to the 5th is approaching infinity. X minus 1 also is approaching infinity. So this limit actually has to be equal to infinity because both of my factors are approaching infinity. So I have two things that are growing huge, and I'm multiplying them. So their product is also growing huge. Another way to look at this is that this is a polynomial, and from algebra we know that the leading term really dominates the behavior of the polynomial. So that's the end behavior, and this polynomial is going to have end behavior that is towards infinity. Here's another example. This is really similar to the examples we did with irrational functions. Here, what I'm going to do is I'm going to divide through by e to the x. Okay, so I have 7e to the x divided by e to the x in the numerator. And I have 11e to the x minus 21 divided by e to the x in the denominator. This gives me and now I can see that as x approaches infinity, this grows huge, so this quotient is approaching 0, and my limit is approaching 7 over 11 minus 0, which is 7/11. The last thing I want to say is just to give you a hint on the homework. So 2.6 number 14, use the squeeze theorem. And please note that 0 times infinity is not 0, it's indeterminate. That means no info. One other thing I want to point out is the indeterminate forms we've dealt with so far have been 0 over 0, that was the first one, and then some form of infinity over another infinity. We had infinity minus infinity, and we had 0 times infinity. There are some other indeterminate forms we'll learn later. But remember that these are not equal to numbers. They're indeterminate, which means that there's no information about the limit. Remember that when evaluating a limit, the first thing you usually try to do is plug in the number, or if it's infinity, you try to see what's happening to the numerator as x approaches infinity and what happens to the denominator. So you're kind of trying to plug things in and see where things are going. But if you get one of these forms, you have to do some algebra.